Welcome to Game Theory. This is section 27 in your text. This is mixed strategies, and we'll go over another example or two. This first example, we want to find any pure and mixed Nash equilibrium points. So suppose we have the matrix as shown below, or excuse me, on the left. So the first thing we want to do is look for pure Nash equilibrium points. So if B plays left, A's best response would be to play up. If B plays right, A's best response would be to play down. If A plays up, B's best response is to play right. And if A plays down, B's best response is to play left. So we have no pure Nash equilibrium points. So now we look at strategies. So let's assign our P and our Q. It's always helpful to write these next to your matrix so you don't lose track of which one's P and which one's Q. So the expected value for A, if A plays up, so we say to ourselves, if A plays up, then we get 2 points every time that B plays Q, plus 1 point every time B plays 1 minus Q. So we can get, again, this is A's payoffs. So let's use some color codes here. So we can do A's payoffs is the red and B is the Q in blue. So we get 2Q plus 1 minus Q. So this gives us 1 plus Q. And so if A plays down, they get 1 point plus 4 points. And it's a matter of how often they get the 1 point. They get the 1 point Q percentage of the time, and the 4 points 1 minus Q percent of the time. So they get 1Q plus 4 minus 4Q. So they get 4 minus 3Q. And so we find Q by setting these particular payoffs equal to each other. So we say 1 plus Q equals 4 minus 3Q. So I like to get rid of the negatives first. So I'm going to move the 3Q to the other side. So plus 3Q. So I'm left with 1 plus 4Q is equal to 4. So then I have minus 1. So subtract off 1 from both sides. So I get 3. And so I get 4Q is equal to 3. So I get Q is equal to 3/4. That means 1 minus Q is equal to 1/4. So Q is the probability that B chooses left, and 1 minus Q is the probability that B chooses right. So I'm going to keep these in mind, so I'm going to box these for later. So I've solved for Q. So now I can solve for P. So I do the same thing. So let me again assign my P's and my Q's. So here's my P, my 1 minus P. So my expected payoff for Q, or for player B, if B plays left, either they get -3 or 1, and it's a matter of which one. They get -3 with probability P and 1 point with probability 1 minus P. And so solving this, we get -3 plus 1 minus P, -3P plus 1 minus P, so I get 1 minus 4P. The probability of right would be 2 plus -1, and so 2% of the time, they get 2 times P, they get 2 times P plus -1 times 1 minus P. So they get equals 2P minus 1 plus P. So they get 3P minus 1. So setting these equations equal to each other, 1 minus 4P equals 3P minus 1. So I move the 4P over, so I get 7P equals 1 minus 4P minus 1. And I, dropped the 4P already. And I add the 1 over, so I get 2 equals 7P. And so this gives me that P equals 2/7. Again, this is less than 1, so this is good. So 1 minus p is equal to 5/7. So p, this is the probability that A plays up, and 1 minus p is a probability that A plays down. So again, we'll hold this. So these are our pure Nash equilibrium points. And now we just need to substitute into our expected values. So our payoff, so we can take our P and our Q, so we can take either way. So our expected value for A, we can choose either of our expected value formulas. Let's go ahead and choose 1 plus Q. Let's go ahead and take this 1 plus Q. Expected value for A of U is 1 plus Q. And we said that expected value is 3/4. So 3/4 is equal to r plus 1. So we expect that to be 7/4. And the expected value for B, we expect that to be, let's say, 3p minus 1. So substitute in P. So we get 3 times 2/7 minus 1. So this gives us 6/7 minus 1. So we get negative 1/7. So our payoff we expect to get is 7/4 for A and negative 1/7 for B for our expected payoff. So let's look at another example here. So we have, again, find the pure in Nash equilibrium. So let's check for pure. So if A plays up, B would play left. If A plays down, B would play right. If B plays left, A would play down. If B plays right, A would not have a choice. So we do have a pure Nash equilibrium point here at right, or at down comma right. So it is okay to have a pure Nash equilibrium. When we're looking for mixed strategies, it's still fine to have a pure Nash equilibrium point. But let's check for mixed strategies as well. It's possible that we could have a mixed strategy as well. So the expected value for playing up. So again, let's write our P and our Q. Our P and our Q and our 1 minus Q. So if A plays up, we expect 1Q plus 2, 1 minus Q, which is equal to 2. And then we have 1 minus 2Q, so we get 2 minus Q. If A plays down, we get 4Q plus 2 times 1 minus Q. So we get 2 plus 2Q. If B plays left, we expect 4P plus 1, 1 minus P. So we get 3P plus 1. B plays right, we get 1P plus 3, 1 minus P. So we get 3 minus 3P plus 1, so minus 2P. Set these equations equal to each other, so we get 2 minus Q equals 2 plus 2Q. So move the Q over, so 3Q. Move the 2 over equals 0. So Q has to equal 0. This is okay, our probability can be equal to 0. Let's check on P. So we get 3P plus 1 equals 3 minus 2P. So we move the P over, so we get 5P plus 1 equals 3. Move the 1 over, so 5P equals 2, so P equals 2/5. So when we look at this, we get Q equals 0, so 1 minus Q equals 1. And 1 minus P equals 3/5. So we've got a strategy here where player A plays a mixed strategy. 2/5 of the time, player A will choose up, and 3/5 of the time, player A will choose down. However, none of the time, player B will choose left, and all of the time, player B will choose right. So let's look at this back in our matrix. So P, 2/5 of the time, player A will choose up, 3/5 of the time, player A will choose down. Q, none of the time, player B will choose left, and all the time, player B will choose right. So this is where part of the pure strategy comes into play. So it's okay that we have a mixed strategy and a pure strategy. So again, we can still find our expected payoff. So the expected payoff for A, we can use either strategy. So we can say 2 minus Q. If Q is equal to 1, this is equal to 2 minus 1 is equal, sorry, if Q is equal to 0, excuse me, 2 minus 0, so equals 2 for A. The expected payoff for B, we can, let's say 2P, so 3P minus 1 if P is equal to 2/5. This is 3 times 2/5 minus 1, or 6/5 minus 1, which gives us 1/5. So our expected payoff for B is 2/5 1/5. So our mixed payoff is 2, 1/5. And our strategy is A would play P as 2/5 and B would play Q as 0. But our pure strategy, A would choose, let's keep this consistent. So at A would choose down at 100 and B would choose right at 100 with payoff 2, 3. So A is getting 2 points out of this, expects 2 points out of this game, and B expects either 3 points or 1/5 of a point. All right, so if you have any questions, as always, please let me know.